Okay, I want to talk about adding fractions, and I want to show you the natural progression from adding fractions with the same denominator to adding fractions with different denominators. So if we add fractions, let's say we add a fraction, and it is, well, first of all, what is a fraction? When we look at the numbers, if I look at this and this is a fraction, then I would say, I put on the bottom of the denominator, I put the number of parts that make a whole. There's 1, 2, 3, 4 parts that make that a whole. If these were all filled in, then we say we have a whole. Now, a fraction says the denominator is the bottom number, which tells me the number of parts that make a whole, and the top number are the number of parts that are shaded or selected. In this case, 1 is filled in. So this is a fraction, 1/4. Let me do that again. The bottom number tells me the number of parts that make a whole. The top part tells me the number of parts that are selected out of the number of parts that make a whole. Now if I was to add this, to this, well, first of all, what fraction is that? The bottom number tells me the number of parts that make a whole. 4. 1, 2, 3, 4. The top number tells me, the numerator tells me the number of parts that are selected. So if I add these two together, what I add is not the bottom number, but the top numbers only, the numerators. 1 plus 2 equals 3 over, and this stays the same because the number of the parts that make a whole is still the same, 4. If I saw this in finished product, I'd have 1 from the first fraction plus 2 from the second fraction, and my answer would be 3/4. Take this. Okay, now, and let's say we add, and we'll what fractions do we have here? Well, what number, the denominator will tell us how many parts make a whole. 1, 2, 3. The top number numerator is going to tell us the number of parts that we've selected or shaded. 1. We're going to add that to this fraction, which is exactly the same. I have 1, 2, 3 parts that make the whole. 1 part selected. And my answer is 1 part plus 1 part gives me 2 parts, but there are still just 3 parts that make the whole. So when I add this together, the 3 is going to go on the bottom, the 2 is on top, because it's still 3 parts that make the whole. Okay, now we're going to change this up just a little bit. What happens if I have this? And I want to add that to this. Now what do I do? Because before I had the same number of parts that made a whole. This time I have 4 parts that make a whole. Then I have 3 parts that make a whole. Well, how do I add those together and get my final product? Okay. This is 1/4. This is 1/3. I want to add those together. You'll remember that before we had the same denominator. Well, actually what we do is we do that exact same thing. We're going to take this and we're going to turn this into its equivalent fraction. Try and remember that. Now how many parts do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh. How many parts are selected? 1, 2, 3. This is what I need you to understand. 1/4 and 3/12 are exactly the same amount or value. They haven't changed. All I did was cut them into more parts. I didn't add any more squigglies. I didn't select any more. I just took that 1/4 and cut it into 12 parts. And so 1/4 and 3/12 are exactly the same. You'll notice all I do was cut the fourths. I cut them into more parts. I cut them into 12 parts, which meant that one part here was cut into 3 parts. So 1/4 and 3/12 are exactly the same amount. Give me an illustration. If I had 2 quarters in this hand and 5 dimes in this hand, I'd have 50 cents in this hand and I'd have 50 cents in this hand. Now, do 2 quarters look different than 5 dimes? Yes. But are they the exact same amount of money? Yes. 1/4 and 3/12 are exactly the same. Now watch. If I use that, can I do that over here? I can cut my 1/3 into 12 parts as well. And what fraction is that? Remember, the number of parts that make a whole is now 12, and the number of parts that are selected are 1, 2, 3, and 4. So now 1/4 is equal to 3/12. 1/3 is equal to 4/12. And what can I do with that? I now have the same denominator. So I now can add up my parts, and the answer is 7/12. If I look at my part here, I'll just make it a little bit smaller so we can fit it here. Oops. And that's 12. And I can say 1, 2, 3, 4, 5, 6, 7. I can fill in 3, 4, 5, 6, 7. And I fill in 7 of the 12 squares. So, we can add fractions with different denominators. We just have to make equivalent fractions to do that. Okay?